Friends, we will take one more example on the type 2, the non-homogeneous linear differential equation. That is example. Solve d cube y by dx cube minus y is equal to 3 times cos 2x. This is a given example. As you know, this is non-homogeneous differential equation. Now, this equation can be written as, okay, d cube minus 1 of y is equal to 3 cos 2x. Okay. So now, let us find first complementary function. That is, there for that purpose we have to write the auxiliary equation. That is, therefore the auxiliary equation is L of m is equal to 0. So that becomes m cube minus 1 is equal to 0. Now this m cube minus 1 is equal to 0. It is in the standard form a cube minus b cube. That is, a cube minus b cube is given as a minus b to bracket a square plus ab plus b square. Here a is equal to m and b is equal to 1 is there. Therefore substituting this a is equal to m and b is equal to 1 in this formula, we will get m minus 1 into m square plus m plus 1 is equal to 0. Now this is one factor, this is other factor. Let us make them equal to 0. So m minus 1 is equal to 0. So one factor, and m square plus m plus 1 is equal to 0 is the other factor. So from this factor, take this 1 to this side, it becomes m is equal to 1, which is one of the root. Now consider the second factor, which is quadratic. Okay, now once it is quadratic, first we need to think of factorization. So this concentrate on this constant number and coefficient of m. So constant number is 1, coefficient of m is also 1, that both are plus 1. So we have to find two numbers such that if you multiply you must get plus 1, if you add you must get plus 1. So two numbers as such are not possible here. So for that purpose we go for Sridhara's rule. That is, already you know what is Sridhara's rule. So that is x is equal to minus b plus or minus under square root b square minus 4ac divided by 2a. Here a is equal to 1, b is equal to 1, and c is equal to plus 1. Substituting all those values in this equation, you will get m is equal to minus 1 plus or minus under square root 1 minus 4 as it is, then into a is 1, c is 1, that is 1 into 1 divided by 2 into 1. So further simplification leads to minus 1 plus or minus, this is 1 minus 4 means you will get under square root minus 3. Under square root minus 3 means you can write that one as root 3 into I whole divided by 2. Therefore you will get roots as, with respect to this factor, you will get roots as minus 1 by 2 plus or minus root 3 by 2i. Therefore you got all the three roots. One root is real and other two roots are complex. So with respect to this, using basic theory, we can write the complementary function as therefore the complementary function is yc is equal to c1 into e to the power x plus e to the power, here real part is minus 1 by 2, so you can write it as e to the power minus 1 by 2 into x into bracket c2 cos root 3 by 2 into x plus c3 into sine root 3 by 2 into x. This is your complementary function. Now let us go to find a particular integral. Therefore the particular integral is given by yp is equal to 1 divided by d cube minus 1 of 3 into cos 2x, 3 into cos 2x. Therefore here if it is d square is present, you would have written directly. Now d cube is present there, so what we have to do, whenever it is sine or cos, so if it is we have to replace the d square by minus a square. Here a is equal to 2 is there, so a is equal to 2 means d square becomes minus of 2 square, minus 2 square. So d cube can be written as d square into d. Therefore you can write this equation as 3 is taken constant common outside, that 1 divided by minus 2 square into d minus 1 as it is of this is cos 2x. Therefore simplify this becomes 3 as it is, minus 2 square is for the negative sign means it will minus 4d minus 1 of cos 2x. Okay, now taking minus sign common here, you can write it as minus 3 into 1 divided by 4d plus 1. Now if it is in this case, if it is sine or cos, you cannot find directly the particular integral. According to the rules, what we have to do, you have to make this d as a d square. For that purpose we need to rationalize this. That is, rationalize means we have to write the conjugate of this. That is, multiplying numerator and denominator by 4d minus 1. So 4d minus 1 divided by 4d minus 1. So it becomes cos 2x. Now 1 into 4d minus 1 is 4d minus 1 only. Operate this on this. That becomes 4d minus 1 to cos 2x divided by, this is of the form a plus b into a minus b. That is a square minus b square. Here a is 4d, b is 1. So 4d whole square, it becomes 16d square minus b square. B is 1 here, b square means it becomes 1. So now operate this on this. That is 4 times d means differentiation. Differentiation of cos 2x becomes minus sine 2 sine 2x. Then plus into minus is minus. So it becomes minus simply cos 2x divided by, wherever d square is there, you have to replace it by minus a square. A is minus 2 here. A is minus 2 means it becomes 4. It becomes 16 into minus 2 square minus 1. So minus 2 square means it becomes 4 minus 4 into this is 64. 64 means it becomes minus 65 minus 1, it becomes minus 65. Therefore now further this minus divided by minus is plus, 3 divided by, you will get this as a 65 minus 3 divided by 65. Here you will get 8 sine 2x, 8 sine 2x plus cos 2x, because minus divided by minus it is plus. So again taking minus common here, you will get this answer. So this is your required particular integral. Now this is not actually solution. To write the complete solution of the given equation or final solution of the given equation, we have to add, that is the general solution is written as y is equal to yc plus y is equal to yc plus yp. Okay, that is yp's particular integral. So we have to add this complementary function plus this particular integral, that gives you the final solution. Okay, now okay, let us take one more example here which is important. Okay, example, solve d square plus 2d plus 2 of y is equal to sine square x. It is non-homogeneous, so solution is given into two parts already, you know. Therefore first we will find the complementary function. Therefore the auxiliary equation can be written as, or auxiliary equation is written as L of m is equal to 0. Remember this is your L of d. Okay, therefore wherever d is there, replace d by m, so it becomes m square plus 3m plus 2. So once it is a quadratic equation, what we have to do, we have to concentrate on this number 2, constant number, coefficient of m, that is 3. So if you multiply you must get plus 2, if you add you must get 3. Two numbers, the two numbers are 2 plus 2 plus 1. It is possible to do the factorization. So if you add 2 plus 1, it gives you 3. Then if you multiply plus 2 into plus 1, that is plus 2 only. So you get, so therefore this can be written as m square plus m plus 2m plus 2 is equal to 0. Therefore from the first two factors, let us take from the first two terms, let us take m common. It can be written as m into m plus 1. So from the second two terms you will take a third and fourth term, you will take 2 common, it can be written as m plus 2. Now you observe here m plus 1 is the common factor. Taking that common factor outside here, you will get from this term m is remaining, from this term plus 2 is remaining. Therefore m is equal to plus 1, m plus 1, m plus 2 are the factors. M plus 1 into m plus 2 is equal to 0. So now on solving this, that is making m plus 1 is equal to 0 and making m plus 2 is equal to 0, you will get m is equal to minus 1 and m is equal to minus 2. Those two are the roots here. M is equal to minus 1 and minus 2 are the roots. Now you observe these two roots are real and distinct. These two roots are real and distinct. Therefore the complementary function according to the case number 1, which we have discussed when we are discussing homogeneous differential equation, it is given by yc is equal to, or complementary function phi of x is equal to, that is c1 plus e to the power minus x plus c2 into e to the power minus 2x. Now we will mainly concentrate on a particular integral, that is 1 pi is equal to y complementary, that is 1 divided by d square plus 3d plus 2 of it is here it is sine square x. If it is sine square x, it is not possible to substitute direct the value of a here. So what we have to do, we have to reduce it to the standard form. So it can be written as 1 minus, using the standard result, it can be written as 1 minus cos 2x divided by 2. That value will substitute, that is 1 minus cos 2x divided by 2. Now 1 by 2 is one term. This can be written as, actually this can be written as 1 by 2 minus cos 2x divided by 2. So operating, this is one term, this is one term. 1 divided by LD is a linear operator. Operating this separately to this term and this term. So first 1 by operating this 1 divided by LD on this, you can write this one as 1 by 2 is constant. You take that outside. You can write this one as 1 divided by d square plus 3d plus 2 of e to the power 0x minus, okay, plus into minus is minus 1 divided by d square plus 3d plus 2 of cos 2x. Now concentrate here. This is e to the power 0x. E to the power 0x means we have to go refer case type 1. So now x coefficient here is 0. X coefficient is 0. Once x coefficient is 0 means that is a is 0 in this case. Now according to the rules, what should happen? We have to check whether this a is equal to 0 is whether it is equal to any of the root or not. Here it is not equal to the any of the roots. It is not equal to the any of the roots. Therefore directly what we will do, wherever d is there in LD, we will substitute d is equal to 0. That is a, d is equal to a is nothing but 0 here. So 0 plus 3 into 0 plus 2. So minus. Now this is a type 2. This is type 2 means that is sine or cos. So wherever a is there, sorry, wherever d square is there, you have to replace this by minus a square. Here in this case a is equal to 2, that is coefficient of x. So you will get 1 divided by minus 2 square plus 3d plus 2. So now of cos 2x, now we will simplify this, that is 1 by 2 as it is. So simplification of this becomes, this is 0, this is 0, 1 by 2. So 1 by 2 into 1 by 2 is 1 by 4. 1 by 2 into 1 by 2 is 1 by 4, plus into minus is minus. So this 1 by 2 is common to this also, so I will write this 1 by 2 here. Now after simplification, this becomes 1 divided by 3d. This is minus 4. Minus 4 plus 2 means it becomes 3d minus 2 of cos 2x. Now again it is d is remaining here, so it is cos 2x there, sine or cos. So what we have to do, we have to try to make this d square. To make this d square, one of the famous rule, what we are going to method, rationalization. Multiply numerator and denominator by 3d plus 2, that is 3d. 1 into 3d plus 2 is 3d plus 2, therefore 3d plus 2 into 3d minus 2 we are going to write here of cos 2x. 1 by 4 as it is, minus 1 by 2 as it is. Now let us simplify this. This is of the form a plus b into a minus b. That becomes a is 3d here, so a square means you will get 9d square. B is 2 here, so b square means 2 square, that is that you will get 9d square minus 4, 3d plus 2 as it is of cos 2x. Now what we have to do, simultaneously we can operate this and we can substitute that d square is equal to minus a square. So operating this on this, what we will get, 3 into differentiation of cos 2x, that becomes minus 2 sin 2x plus 2 into cos 2x, 2 into cos 2x. 9 into d square is minus a square, means 9 into minus 2 square minus 4. So now let us simplify this. 1 by 4 minus 1 by 2, this is 3 2 is 6, minus 6 sin 2x as well, plus 2 cos 2x. So just minus 2 square means it becomes minus 4. Minus 4 into 9 is minus 36. Minus 36 minus 4 is minus 40. Now again this minus this becomes plus, so I written here 1 by 4 as it is, minus divided by minus plus. So 1 by 2 into 1 by 40, if you take that outside, that becomes 1 by 80. Then here you can write this one, this is with the positive sign, so you can write this one 2 cos 2x minus 6 sin 2x. This is the required particular integral. Therefore this is your particular integral. Already you got the complementary function here, so the general solution is written as y is equal to yc plus yp. Okay, if you wish, we'll take one more example here. Okay, let us take one more example here, that is solve d square into d square plus 4 into d square plus 9 of y equal to 2 times sin x by 2 into cos x by 2. Okay, now therefore the auxiliary equation in this case, it is written as, this is completely your L of d. The auxiliary equation is written as L of m is equal to 0, that is wherever d is there you have to replace that d by m here. So that becomes m square into m square plus 4 into m square plus 9 is equal to 0. Now nothing to worry here. So if you multiply, you will get m raised to 6 here. If you simplify all these things, so you have to get 6 roots of this equation. So to get the 6 root of the equation, so already 3 factors are there, make them equal to 0. The m square is equal to 0, m square plus 4 is equal to 0, m square plus 9 is equal to 0. Therefore this equation can be written as m is equal to 0, m is equal to 0. Therefore directly you can write m is equal to 0, 0 is 2 roots. Then this can be written as m square is equal to minus 4, minus 4. So m is equal to, you will get plus or minus 2i, and this can be written as m square is equal to minus 9. On simplification, you will get m is equal to plus or minus 3i. Therefore you got two real roots, two complex roots. These with respect to one factor you got two complex roots, with respect to other factor also you got two complex roots. Total you got 6 roots. So with respect to this we have to write the complementary function. Therefore the complementary function is with respect to 0, 0, you can write real roots, that is c1 plus c2x into e to the power 0x you can write, but e to the power 0x is 1, so you will write this one as c1 plus c2x plus. Here real part is not present, so directly we can write with respect to imaginary part beta is equal to, you can write c3 into cos 2x plus c4 into sin 2x. Okay, now with here also real part is not present, with respect to beta is equal to 3, you have to write a complementary function as c5 into cos 3x plus c6 into sin 3x. This is the required complementary function. Now we will concentrate on finding the pi. That is, pi is given by yp is equal to 1 divided by LD is d square into d square plus 4 into d square minus 9 of, I will write this one as 2 times sin x by 2 cos x by 2. This can be written as using half angle formula. This can be written as sin x, because you already know sin 2x is written as 2 times sin x by 2 cos x by 2. Okay, or you can so using the standard result, sin 2 theta is equal to 2 times sin theta by 2 into cos theta by 2. So it becomes sin x. So here a is equal to 1 directly. If it is a is equal to 1, what is the rule? You have to substitute wherever d square is there, you have to replace that by minus a square. So this becomes a minus 1 square plus 4 minus 1 square plus 9. Therefore simplification leads to 1 divided by this minus 1 as it is. This is minus 1 plus 4, it becomes 3, minus 1 plus 9, it becomes 8. So finally if you simplify, you will get sin x divided by 8 3 is 24 into minus 1. So pi, required pi is minus sin x divided by 24. This is your pi. Now to write the general solution, what you have to do? You have to add the complementary function and a particular integral. Therefore the general solution is given by y is equal to yc plus 5. Okay, now let us take one more example to conclude the method type 2 examples. Okay, example, solve d cube y divided by dx cube plus y is equal to 65 times cos 2x plus 1. It is of the form ax plus b. Here b is equal to 1, k is equal to 65, and it is a is equal to 2. So in this case we have to always will be concentrating more on the coefficient of x. Okay, now so this equation can be written as d cube plus 1 of y is equal to, this is at 65 times cos 2x plus 1. Nothing to worry about this. Don't use expansion formula or cos a plus, don't use cos a plus b formula. Let us keep that as it is. Okay, now this can be written as the auxiliary equation is written as m cube plus 1 is equal to 0. No, m cube plus 1 is equal to 0. If you want, you can use a synthetic division method here, but we already have one of the standard formula with respect to that, that is a cube plus b cube is equal to, already you have this standard formula, a plus b into a square minus ab plus b square. Using this formula, here a is equal to 1, b is a is equal to m, b is equal to 1. You can write this equation as m plus 1 into m square minus m plus 1 is equal to 0. So this is one factor, this is other factor. Now make this m plus 1 is equal to 0, solve this, you will get m is equal to minus 1 as one of the root. Now This is other factor is quadratic equation. So you have to, once it is quadratic equation, consider the constant term, it is 1, middle term is -1, coefficient is -1. So try to factorize this. If you multiply, you must get 1. If you add, you must get -1. Two such numbers exist. Two such numbers does not exist. So factorization is not possible. So we'll go for Sridhar's rule. That is m is equal to here. Already you know a is 1, b is -1 and c is 1. Therefore you can write this one is m is equal to minus of -1 becomes +1 plus or minus under square root b square, that is 1 square is 1 only, minus 4 into a into c, that is 4 into 1 into 1 divided by 2 into 1. Now on simplification this becomes 1 plus or minus, this becomes under square root -3 divided by 2, which can be written as 1 by 2 plus or minus root 3 by 2 times I, because root 3 as it is, root 1 is I. Okay, therefore now all the three root, this is a cubic equation, means you have to get all three roots. You got all the three roots, one root is real, other two roots are complex in nature. Therefore with respect to that, let us write the complementary function cf as yc is equal to c1 into e to the power minus x plus real part is 1 by 2 here, that is alpha is 1 by 2, beta is root 3 by 2. So you can write this one as e to the power 1 by 2 into x into bracket c2 into cos root 3 by 2 times x plus c3 into sine root 3 by 2 times x. This is required complementary function. Now let us concentrate on the particular integral. The particular integral is 1 divided by d cube plus 1 of 65 times cos log 2x. Now since this 65 is constant, let us take that outside the operator, and it is a sine or cos, it is there. So sine or cos means we have to replace d square by minus a square, but here d cube is available, d cube is given. So d cube is given means we have to write that d cube as a d square into d. Now wherever d square is there, you have to replace it by a. Where is the a? A is nothing but a coefficient of x, that is this. A is equal to here 2 in this case. So replacing d square by minus a square, it becomes minus 2 square into d plus 1 cos 2x plus 1 as it is. So 60 as it is, it becomes 1 divided by minus 4d plus 1 of cos 2x plus 1. Now d is remaining here, here it is cos there. So now to find the pi in the easiest way, what we have to do, we have to make this d square. For that purpose what we need to do, we need to make this d square, we need to rationalize this. Rationalization means multiplying numerator and denominator by conjugate of the denominator. Here denominator is minus 4d plus 1, or you can write it as 1 minus 4d, no issues. So minus 4d plus 1 can be written as minus 4d minus 1 minus 4d minus 1. Okay, we have to multiply. Okay, then cos 2x plus 1. Now let us simplify this. Okay, that is 65 will keep as it is. Now sorry, here 65 as it is, this is 4d minus 4d minus 1, let us keep that as it. Now this is of the form a plus b to a minus b. So a is minus 4d here, b is 1 here. So on squaring you can write this one as minus 4d minus 1 in the numerator as it is. So it becomes a square means minus 4d whole square minus b square 1 means 1 square. So operating this 4d on this minus as it is, differentiation, d means differentiation of cos 2x plus 1 is minus 2 times sin 2x plus 1 becomes minus, then plus into minus is minus, it becomes cos 2x plus 1. Now here minus 4 whole square means minus 4 square means it is a 16 square, d square, wherever d square is there you have to replace this by minus a square. A is 2 here, so it becomes minus 2 square minus 1. So it becomes 65 into, it is minus into minus plus here, minus into minus plus, 4 2s are 8, 8 times sin 2x, 8 times sin 2x plus 1 minus as it is cos 2x plus 1. Now this is 16 into minus 4 is minus 64, minus 64 minus 1 is minus 65, you can write 65. So therefore what happens here, this 65 and 65 get cancelled, so you left with 8 times sin 2x minus cos 2x plus 1 divided by minus 1 is there. If you take this minus sign inside, so you will get a plus cos 2x multiplying it by minus sign plus cos 2x plus 1. So this plus into minus becomes this minus 8 times sin 2x plus 1. This is your required particular integral. It's not the complete solution. This is the only particular integral. Therefore, the general solution is written as, the complete solution is written as y is equal to yc plus yp. So this completes the examples of type 2.